Hello friends, this is Vimal for VTP channel. Today we are going to discuss about some of the expressions in and the formulas related in motion in a straight line. So we are going to do some of the formulas and few problems related to it. So that is the first part we are going to see today. The first formula is, so say for example when a body covers first half distance, that is first a body covers first half a distance with the velocity v1 or speed, you can take it over, and the next half with the speed v2. So first half in v1 speed and second half in v2 speed. Then the expression for average speed is given by v bar, which is nothing but equal to 2 times of v1 v2 by v1 plus v2. So here we are going to find the expression. That is the first expression. So average speed is given by twice v1 v2 by v1 plus v2. So that is the expression if there are two borders in this particular relationship. The next part of the problem is, the next formula is, if the body covers 1/3 distance in the first half, in the first part, 1/3 distance, and another 1/3 with velocity say v2, and then the third 1/3 with, and the third part 1/3 with the velocity v3. So now what could be the average speed? So that is the next part we are going to do it. So the average speed is given by the formula average speed v bar is equal to, so here three terms we are given. So it is, so 3 into v1, v2 and v3 by, so v3 into v1, v2 by v1, v2 and v3 by v1, v2 plus v2, v3 plus v1, v2. So this is the expression we are going to see it. So v1, v2, v2, v3 and v1, v3. So they are the first expression we are going. So average speed is equal to 3 v1, v2, v3 by v1, v2, v2, v3 and v1, v3. We are adding all these three. So this is the second equation we are discussing. So for first and the second. Now the third we are going to discuss is nothing but free fall. What will happen at the free fall? So free fall means the object falls freely with respect to gravity. No other forces are acting over it. So we are going to give out three conditions over here. So during the free fall, velocities will be constantly ranging, because as it is approaching towards the ground, its acceleration also increases because it is coming towards the ground. So the acceleration also increases. Now we are going to see out what will be the distances covered in the first, second and the third second, and what could be its acceleration. So that is the part we are going to see. So if then the distance is covered, so we are going to see it. So distance is covered in the first, second and the third second. So it will be how they are related. So that is the next question. That is the next discussion we are going to have. So what could be its distance and what could be its acceleration after considering these parts. Now I am going to draw the diagram. So the next part is I am going to draw the diagram of just a diagrammatic representation to make it this problem to be understood clearly. So that is the next part I am going to do. So first the object is falling down, so it is a free fall. So I took it as free fall. So free fall means it is starting from rest. So at t equal to 0, it starts at 0, t equal to 1, at t equal to 2, and the final t equal to 3, because these are the expressions which has been given. So first thing, it is falling from a particular height, so you should take into account u equal to 0. So that part you should be very careful with. You should not omit any part of it. So rest means u equal to 0. So that part you should be very careful. So you should be keeping that in mind very clearly. Now what could be the relationship? So from 0 to t1, it took almost 9.8 meter per second square. That is the first acceleration. So 0 to 1, it is 9.8 meter per second square. For next part, that is from T1 to T2, it is the second. So 0 to 1 it took 9.8, whereas from T1 to T2 it is 19.6 meter per second square is the acceleration. So what could be that for the third one, T2 to T3? So it could be 20. Yes, it is 24.5 meters. So these relationships, if they asked, you need not go and solve for this. So that is why the formulas and some of the ideas has been given. So these values you can keep in your mind. So for first it is 9.8 meter per second squared. From first to second it is 19.6 meter square. And from second to third it is 29.4 meter per second square. So what is the distance? So it is 4.9 meters for the first case. In the second case it is, so first one is 4.9, whereas the second one, so one by one we are going to list out. So acceleration as well as distance, you just keep in your mind, that is more than enough. So first one is 4.9 meter, whereas second one is, it is 14.9 meters, and the third one is, so third displacement is it is 24.5 meters. So these are the distances you should be keeping into account. Now we are going to see about the so on the first, second and third second, so these are the conditions which are given. So 0, 1, 2, 3, it's accelerations. First one, that is second one, and the third one we have discussed. And now we are going to see the displacement also. So these things you should be keeping in your mind clearly. So make sure that you are not making any errors in this particular part. So now the first part, that is the next part of the problem set, is over. Now we are going to another set of problems. So another formulas we are going to discuss. So whenever telling an equation in a straight line, so we can equally come to this only one conclusion we have to discuss, that is nothing but equations of motion. So that is the next part we are going to discuss, is nothing but equations of motion, because without that there is no motion in a straight line problems. So the next formula which we will be discussing is equations of motion. So that's what I am going to do it next. So equations of motion. So as I discussed, there are three equations of motion. So you already know that. So first one, it is nothing but v equal to u plus at. Then the second one, the first one, v equal to u plus at, is nothing but v is final velocity, u is initial, and a is acceleration, and t is time taken. And the second one, s is equal to ut plus half at square. So here s is displacement, u is initial velocity, a is acceleration, and t is time taken. And the third equation is v square equal to u square plus 2as. So these are the three equations of motion which you have learned in your lower standards. There are additional two more when you are coming to higher standards. So fourth one, I think it will be in an 9th standard also. S is equal to, the fourth one expression is S is equal to, so that is that S is equal to u plus v by 2 into t. This expression I know that you are discussing in 9th, I think. Fifth, and the final expression is distance traveled in the nth second. So which is somewhat you will be learning only in the 11th. So distance traveled in the nth second is given by the formula. So already know that only the formulas we are going to discuss. So distance traveled in the nth second is given by Sn, where Sn is nothing but displacement. Sn is equal to, it is u plus a by 2 into 2n minus 1. S is equal to u plus a by 2 into 2n minus 1 is the fifth formula we are going to discuss. So that is the expression. So these are the 5 equations of motion we are going to discuss. The fifth one is especially when the object is falling towards gravity, that is downwards if you take into account. So it is falling towards gravity, therefore AS has to be taken as plus G. And when you are throwing up away from gravity, that means you are throwing an object upwards, so A is taken as minus G. So these parts you should be very clear with. So when the object is coming down, it is plus G, and the object is thrown up, it is minus G. So the direction is important, because in problems you should be very careful when you are applying these two conditions. So that is more important part. Now we are going to see how those expressions are going to alter the different equations of motion. So that is the next set of formulas we are going to discuss. So how the expressions that is when you are throwing upwards or downwards, how they are changing the equations of motion we are going to see. Instead of A, I am going to replace it as G. So that is it. So the first one we are going to discuss is, say for example, the object is coming down. So that is the first case we are going to discuss. So body is automatically thrown downwards. So body is thrown. So body is thrown downwards. So that is the next part. So how we are going to discuss how the formulas are being related with. So the equations of motion you already know that. So now I am going to write down one by one. So the first equation of motion we know that it is V equal to U plus AT. So it is downward, so it is taken as plus G. So for this the first condition we have to take into mind. So as it is coming down, we have to take it as plus G. So V equal to U plus GT is the first expression. Second one is, so A equal to plus G we are taking. So that is how we are going to do it. So V equal to U plus GT is the first one. Second one, S is equal to UT plus half GT square. So instead of A, I am just replacing it as G. And the third one, it is V square expression. V square is equal to U square plus 2AS. Instead of A, I took it as G. U square plus 2GS. S equal to H. And for the nth second, I take it as it is U plus G by 2 into U plus, for the nth second it is H nth second, it is nothing but U plus G by 2 into 2n minus 1. So the same formula I am going to rearrange it. If you take the initial velocity especially, so if you are dropping an object, say for example for some particular height, so if I am taking that U as 0 because the object is at rest. So say at a certain height you are dropping an object. So in those cases you have to put U equal to 0. Therefore the first equation becomes V equal to GT, whereas the third one becomes V square equal to 0 plus 2AS. So V equal to root of 2GH, and H is equal to, second equation becomes H is equal to, instead of U goes off, therefore H is equal to half GT square. So Hn will be, it is nothing but G by 2 into 2n minus 1 as U term is 0. So these are the expressions, or these are the equations of motion which we are taking into account. So now we have found out the condition in the case that is the objects are coming down, that is towards gravity it is falling. Now the second part in this is when I am throwing upwards, what will happen. So now I am going to slightly alter the expression. So when I am throwing the object upwards, what is the condition? So I am throwing it upwards. So body thrown upwards. So the first thing is A will be taken as minus G. So on the plus sign I am removing it and take it as minus G. So it is G is, so that is the first thing I have to take into account as the object is thrown up. So now one by one I am going to check, I am going to substitute in place of plus G as minus G. So that is how we are going to change the expression. So instead of G, that is I am taking it as A equal to minus. Instead of plus I take it as minus. So the first section becomes V equal to U plus removed. So U equal to U minus GT. Second one as UT minus half GT square, and third one as V square minus 2AS. Sorry, GS. So it is Therefore, nth second equal to u minus g by 2 into 2n minus 1. So these are the conditions we are going to take into account. So this, we are coming to the end of the formula session. Now we will be continuing with the problem section. So I have planned to go with 5 problems added to it. So after this, we will be continuing in the problem section one by one. So I will be discussing about more formulas in the upcoming videos. So now we are going to the problem section 1. So now we are going to discuss about the problem number 1. A body starts from rest and moves with an uniform acceleration. The rate of the distance covered in the nth second to the n second is given below. Now we are going to solve it. So as per the discussion, we are given the formula here. Therefore, body is falling down from rest. Therefore, u is taken as 0. So since the object is falling down, you should take it as u from rest. Put u is equal to 0 is the most important condition. Now the next one is the distance covered in the nth second formula you are using. Therefore, Sn equal to u plus g by 2 into 2n minus 1. So it is S equal to u plus g by 2 into n minus 1. So as u equal to 0, the first term goes off, u equal to 0. I substituted it plus g by 2 into 2n minus 1. So Sn is equal to g by 2 into 2n minus 1. So this I take it as one equation. So I take it as equation number 1. So for the nth second you have given the expression. Now we have to go for the n seconds. So it is the second part. So from the second equation of motion, we do have S equal to ut plus of at square. Once again here, as it is coming down from rest, u is equal to 0. So when I substitute it, the expression becomes equal to 0. I am substituting it. Therefore, the expression becomes, and t is substituted as n. So when I am substituting it from the expressions, we can put it as S is equal to, so S is equal to u is 0, so 0, 0 plus of a, instead of t I take it as n square. So S is equal to of an square. I take that as equation number 2. Now if I divide both the expression, I will get the ratio. So 1 by 2 equals Sn by S. Sn by S will be equal to, so it is a by 2 into 2n minus 1 divided by an square by 2. So it is an square divided by 2. So 2 and 2 we can get in cancel. So we can directly remove it. So both expressions I am removing the 2. Yes, 2 and 2 I am getting cancelled. So I get the, rewrite the expression I get. It is a into 2n minus 1. A into 2n minus 1 divided by a into n square. Once again a and a getting cancelled. So 2n minus 1 by n square. We can write it as 2n by n square minus, so a by n, a getting cancelled. We get 2n minus 1 the whole square. That is 2n minus 1 by n square. I got it. Now we can, as we are when you are checking the expression, see I have to relate it, the answer, this is the answer I got. I need to relate it with the problem. So I have to find out which answer suits it. I think the first one will be suiting when I am substituting it. See here it is 2 by 5. So it is 2n by n. So 2n by n square, n and n getting cancelled, we get as 2 by n minus it is 1 by n square. So of subdivision A is supporting the answer. So that is how we are going to find it. So here is the, so problem number 2. the water drop falls at regular intervals from a tap 5 meters above the ground. The third drop is leaving the tap at instant the first drop touches the ground. So how far above the ground will be the second drop? So that is the question. So now we are going to prove it. So let t be the time interval between them, the drops at any instant. So the first one has reached the ground, whereas the second one is in midway, and the third one is still it is being released from the tap. So the first one has reached the ground, second one is midway, and the third one is just released. And they are asking to find us what will at how far the second droplet will be from the ground. So that is the part they are asking. So total height from the first to the third drop is 5 meters. So third to second I take it as x, and second to first I take it as, so to make it simple, to make the problem simplified. So third to second I take it as x, whereas from second to first I take it as h. So when I am substituting the relation, we can easily get the solution. So this is we have to first interpret these sort of problems by means of a diagram to make it clarified. So if you draw a diagram, we can come to a solution how to proceed. So those will be those are the things very important. So that is why I am drawing the diagram. So an exact replica and interpretation of what is given, if you sketch it out in a diagram, it is easier. So the third drop when it is about to release. So what will be the thing? So here they are worried about displacement. So I'm using the second equation of motion. S is equal to ut plus half gt square. So since the third drop is just released, I take u as 0 and it is coming towards the ground. Therefore, a is taken as plus g. So these are the things I am taking into account. So u as 0 and a as plus g. So when I'm substituting it, so s is 5 equal to 0 plus half gt square. So s is equal to 0 plus half gt square. So that is the first expression, I got it. So for the third drop, the time is, so half gt square is equal to 5. So the time for the second one is taking it as 2t. Therefore 5 equal to, because it is taking the time, half into gt square. So instead of t, I substitute as 2t the whole square. So half into g into 2t the whole square, I took it over. So half into g into 2t the whole square. Therefore gt square, just I am making the expression. Therefore instead of gt square, I am just rearranging it. Therefore it is, sorry, just a second, I will just rearrange it. It is g by 2 into t. I am expanding it, so it is 4t square. So I am cancelling it out 2 times. Therefore 5 is equal to, or 5 by 2 is equal to, it is g into t square. I have not expanded it. So 5 by 2 is equal to g into t square. That is the expression for the thing. So for the second drop to come down, so we are going to see it. So how far it is from the distance. So for the second one, I take it as x, because the displacement I take it as x. So it is x equal to half gt square. So that is what I am going to take it over. So x is equal to half into gt square. So now I am going to substitute it. So it is x into, x is equal to half into, instead of gt square, I can substitute it as 5 by 2. So half into 5 by 2. Therefore, you can get it as 5 by 4. So I am taking it as x is equal to 5 by 4. So when I am substituting it, it is almost, when I am dividing 5 by 4, it is almost 1.25 meters. So x is equal to 1.25 meters is the final expression. But we have to find out h. Therefore, h is equal to, so how far it is from the second, from the ground they are asking. So we have to find out h. Therefore, h is equal to, what is this expression? Total distance is 5 and we have calculated x as 1.25. So it is simple, 5 minus x. So it is 5 minus x. So it is 5 and the value for x is 1.25. When I'm substituting it, the expression becomes 3.75 meters. So when I check the answer, the subdivision C is suiting it. So the answer will be 3.75 meters. I have given the screenshot of the entire problem. If you're not able to get it, you can have a look at it. We can have the, so this is the problem. I have given the screenshot. Let us meet in the third problem. And the opposite directions are put on the same track. The drivers notice the mistake around when the trains are 300 meters apart. So we have to see where the train will come and stop. So it is the problem. So they are giving you the graph. I have redrawn the graph here. So when the graph is given, then they are giving you 4 options. So we are going to see which one is suiting it. So which option is correct? We are going to substitute it and we are going to calculate it. So the next one is, I'm going to separate into the graph. So because solving it, it is a graphical problem. So train A and train B, take it over. For train A, t is taken along the x-axis in seconds and velocity meter per second along the y-axis. So I'm plotting the graph. It is given as 40 along velocity. It is 40 and in time axis it is around 10. So that is the graph they are given. So along y-axis it is 40 and along x-axis it is 10. That is what is given. Now I go for graph 2. That is the same graph, x-axis and y-axis. T I am taking along x-axis, but here they are giving in the negative axis. That is negative. That is, it is their velocity is they are given in the negative y-axis. So it is minus 20, and the time taken is they are giving it as 8 seconds. So that is it. Now we are going to follow the problems. So here it is, they are asking you to find out the displacement. So displacement can be calculated by finding the area under the curve in the velocity time graph, whereas the acceleration can be found out by using the slope under the curve. So since they are asking the displacement in the velocity time graph, I am going to substitute the area. So say you can check it over, it's a triangle. So when I am checking the area, it is nothing but a triangle. So the displacement is equal to area of the triangle below the curve, that is along the curve, and forms a triangle. So it is half into base into height. So half into b into h. So along the x-axis I take it as base, along the y-axis I take it as the h. So it is half into 10 into, that is the value is 10 into the thing y-axis is 40. So when I'm cancelling it out, 2 and 5 times, so get it as 200 meters along the first part. So it is around 200 meters the first train A. Now I'm going for train B to find the solution. So once again the same formula, half into base into height, because it is also triangle, but it is in the negative axis, you should be careful with. So same base and height, so half into the base is nothing but 8, I take it as it is, whereas h, that is the height, is I take it as minus 20, because they are giving it along the negative axis. As they are giving it along the negative axis, I will take it as minus 20. So that is important. The negative sign has to be important. So now I am cancelling it out 2 and 4 times. It is 8. So it is 4 into 20. It is nothing but minus 80 meters. So the first train is around 200 meters. The second train is around minus 80 meters. So I am going to interpret it by a small diagram to make it clarified easily. So these will be the positions of the train A and train B. So the total distance between the trains is nothing but 300 meters. I am drawing it as 300 meters. So train A exactly travels to 200 meters. So as per the calculation, I call it as 200 meters. So distance of the first train is around 200 meters. Whereas the second one is coming in the opposite direction is 80 meters in short. So it is at 80 meters. So what could be where the trains would have stopped? So that is a small gap, which is nothing but 200 minus 80. So exactly before 20 meters, the train stops, preventing the accident. So the train will be stopping exactly before 20 meters. That is how we are calculating it. So the screenshot of this problem is given in the next page. So to make it understand it clear. The video is not quality. So the train will be stopping at 20 meters. So that is the next slide. I'm going to use it. So this is it. To make a screenshot so that you can better clarify it if the video is not. So the fourth problem is a stone falls freely under gravity. It covers distances h1, h2, h3 in the first 5, next 5 and the third 5 seconds. So we are going to find out the relationship between all the three of them. So they are given you the options. Now we are going to see how we are finding the result. So a single stone is falling down. So here we consider a stone is falling down. So that is, it is falling with respect to gravity. So when you are telling it is falling with respect to gravity means we call it as a free fall. That is the first thing we have to keep into mind. So a free fall occurs. So when you are telling a free fall occurs, that is, so I am taking three parts. So h1, h2 and h3. So that is the three heights we are getting. h1, h2 and h3 are the three heights. We are doing it. So for reaching h1 height, it took 5 seconds. So that is what we are going to inculcate here. For the next h2 seconds, it was 5 seconds. So I am giving 5. So for h2, it was another 5 seconds. So totally 10. For h3, it was another 5 seconds. So totally 15. So now we are going to inculcate those things in the problem. So t1 is equal to 5 seconds. First. Second, t2 is equal to 5 plus 5, which is equal to 10 seconds. Whereas t3, so t3 is equal to 5 plus 5 plus 5. So totally it is 15 seconds. So that is these are the inferences we are obtaining from the question which is given to us. Now we are going to solve it one by one. So first thing we have to consider is it is a free fall and the object is falling down. So it is falling from rest. Therefore you have to take it as u as 0. That is the first thing you have to consider into account. So you should take u as 0. There is no other option. So this is the first thing you should be keeping in your mind. That is the first part. So as an object is falling down. So we are using the second equation of motion here. So s equal to ut plus half at square. So half gt square we are giving it over. Therefore t1. First part we are going to find out t1 is equal to h1 which is equal to u substitute as 0 plus half into g into 5 square. So I am cancelling it off, half and so half into, that is 2 and 5 getting cancelled. So I am getting it as 2 minus 5 which is nothing but 10. So the 2 and second I am 2 and 10 I am cancelling it out. So I get it as 5. So 5 into 125. So 5 into 25 is nothing but 125. I am getting the relationship. So that is what we are doing here. The next thing is I'm going for h2. Yes, we can find out for h2. So h2 after 5 seconds, it is taking after 5 more seconds. So instead of writing that as h2, it is h1 plus h2. We can write this over h1 plus h2 equal to half into g into time taken as 5 plus 5 whole square. So half into g into 5 plus 5 whole square. I substitute the relationships. So 2 and 10 I cancel it as 5. 10 square is nothing but it is 100. So 5 into 100 it is nothing but 500. So 500 meters is the second point which you got it. So h1 plus h2 equal to 500. So what could be h2? So h1 plus h2 is equal to 500. That's what we have found out from the expression. So we can find out h2 by nothing but 500 minus h1. So that is what we are going to do it. So h1 plus h2 is equal to 500. Therefore you get it as, we are substituting in the relationship. So h2 is equal to 500 minus h1. So h1 is 125. So when I'm substituting it, so we get it as 500 minus 125, which is nothing but 375 meters. 375 meters. That is the next part we are getting. So the next part is the last and the final part. So first part h1 got as 125, h2 as 375. So I take it as the first and second. Now the third part for 5 more seconds. So after 5 more seconds, that is after 5 more seconds. So what we can write, it can be written as h1 plus h2 plus h3 is equal to half into g into time taken as 5 plus 5 plus 5 the whole square. So it should be half into 10 into 5 plus 5 plus 5 is nothing but 15 square. So I'm doing it as half into 10 into 15 square. So when I'm this 2 and 10 getting cancelled, you will get as 5. So 5 into 15 square is nothing but 1125 meters. So h1 plus h2 plus h3 is equal to 1125 meters. Therefore, what could be h3? Therefore, h3 is equal to 1125 minus h1 plus h2. So 1125 minus 125 plus 375. So when I'm cancelling it out, we get it as 625 meters. So we got the expression as 625 meters. So when I'm looking into the expression, h1 is 125 meters, whereas h2 is equal to thrice of it, 375 meters, and h3 is equal to 5 times of it, so it is 625 meters. So it is so simple. From this expression, you can write it as h1. So from the how they are related, so when I'm getting h1, which is nothing but equal to, so I'm substituting the expressions. So we can see that it is 3 times and it is 5 times. So h1 is equal to, so I'm going to find it. So check the equations. So h2. So when I'm checking out all the 3 expressions, we got it as, therefore the expression becomes h1 will be equal to, when I'm checking it over, it is 375. So I write it as, we can write them that particular expression as 3 times of h2, that is 3 times of h1. So h1 is 125, so we can write as h2 by 3, whereas equal to h3 by 5. So always we get it as 125 meters. So this is the expression, we got it. So the quality is very low. I will try to rectify the video issue in the next coming videos, upcoming videos. To make it clarified, I am just giving you the screenshot of this particular version. So this is the expression. So in the next part, I will try to rectify this particular error. So I am giving you the resultant expression. So the last final video, I am giving it here. So this is it, the final expression which I am giving. So we can see in the next video. So the velocity of a particle v is equal to at plus bt square. A and b are constants, and the distance traveled between 1 and 2 seconds is, we are going to see what is the solution, or which answer is suiting it. Therefore v is equal to at plus bt square is the problem, is the expression which has been given. So v is equal to ds by dt, that is velocity is equal to rate of change of displacement. So v equal to ds by dt, I wrote it. Therefore ds is equal to v into dt. Therefore ds is equal to v into dt. Therefore s is equal to integral over ds, that is nothing but integral over 1 to 2. I am going to substitute the limits. So integral over at plus bt square into dt. I am going to substitute the limits. The limits are between the first and the second. So it has been, the limits will be from 1 to 2. So I am going to substitute as 1 to 2 are the limits. So 1 and 2. Now we have to simply, it is a very simple integration. We are going to solve it. So integral over ds is nothing but s. So I am splitting up the equation. So integral of 1 to 2 at into dt plus integral of 1 to 2, that is bt square into dt. That is the expression. So now I am going to apply the formula. So it will be, a is common, I took it outside. So it is integral of t into dt 1 to 2 plus b into integral of t square into dt 1 to 2. I substituted it. By using the formula integral of x power n dx is equal to x power n plus 1 by n plus 1. I am using the formula as x power n plus 1 by n plus 1. So now I am substituting the relationships. I am going to substitute that particular formula in the integrals, and I am going to write it, therefore, which is equal to a into t power 1 plus 1 by t power 1 plus 1 by 1 plus 1 within the limits, which is nothing but 1 to 2, and it is b, I am taking it outside, t square plus 1 by 2 plus 1 within the limits 1 to 2. So I substituted 1 to 2 and the limits I have given 1 to 2. So here now I am expanding it. So it is a by 2, I take it outside. So it is by 1 plus 1 is nothing but 2. So I take it as a by 2. So it is a by 2 So I take it as a by 2 I take it over. So it is a by 2 into t square within the limits 1 to 2 plus b by 3 into t cube 1 to 2. I am substituting the limits. A by 2 into so I am substituting the limits here. So it is 2 square minus 1 square minus b by 3, that is plus b by 3 into 2 cube minus 1 cube. So sorry, so it is a by 2 I written as 2 minus 1, it is 4 minus 1, sorry, it is 4 minus 1, an error has occurred, 4 minus 1 plus b by 3, 2 minus 1, that is 2 square, 8 minus 1, you will get it over, 2 cube minus 1, it is 8 minus 1. So I am substitute here, it is 3a by 2 plus 7b by 3. So it is substituted 3 by 2a plus 7b by 7 by 3b will be the answer. So given the screenshot here, sorry, that 2 square term 2 minus 1, it is 4 minus 1, there is an error, please rectify it. That's the end of the video. Meet you in the next video.